I'm Surendra, Department of CSCB. Today, me and my team telling about preparation of nanoparticles. Introduction of nanoparticles. Nanoparticles are solid colloidal particles arranging from 1 to 100 nanometers in size. They consist of micromolecular materials in which the active ingredients, drug or biological active materials, is dissolved. There are so many methods of preparation of nanoparticles. Like we can see dispersion polymerization method, solvent evaporation method, solvent diffusion method, and dialysis method, and etc. There are so many is there. Now my friends will explain about these methods.
Hi, hello everyone. This is Hemant, Department of CSE from Hindustan University. I'm telling about methods from preparation of nanoparticles that we can see.
Supercritical fluid technology by the formation of nanoparticles. Supercritical fluid technology, the short term is SFC. It is divided into two branches, two types. These are rapid expansion of supercritical solution and another one is supercritical anti-solvent. So these are two different techniques under the supercritical fluid technology by the help of which we can prepare the formation of nanoparticles. We can discuss the another method. Rapid expansion of supercritical solution. So the process of rapid expansion of supercritical solution is firstly drug dissolved in supercritical fluid. Then the solution is spreaded into regions of low pressure. Then the solvent of power of supercritical fluid decreases and then we can get a precipitation of nanoparticles. So this is matter by which can make nanoparticles through the first technology of supercritical to the that is rapid expansion of supercritical solution. Next method comes to supercritical anti-solvent method. It's known as SCA method. In this method, the drug is dissolved in methanol. Then the drug it's completely dissolved. And then it is supercritical fluid. It's added that supercritical fluid thus do miscible with methanol. Then again it's spread as lowest pressure area. Then precipitation of drug as fine particles is recovered supercritical anti-solvent method. It helps us to get nanoparticles with the help of methanol by which we can recover nanoparticles.
I am Sumant, Department of CSC, Section B. Let's get into the topic. Solvent evaporation method. It involves emulsification of a polymer in aqueous phase and dispersion in a volatile solvent like dichloromethane, chloroform, and ethyl acetate. And it also evaporated using high temperature, vacuum, or by continuous stirring. Solvent diffusion method. It consists in the formation of conventional water emulsion between a partially water miscible solvent containing the polymer and the drug and an aqueous solution containing a surfactant. Double emulsification method. Drug in inner aqueous phase and the polymer and drug in oil phase. Agitation as primary emulsion in water and forms secondary emulsion of solvent removal. Oil, water or water, oil, water double emulsion is one method by which can we use it to encapsulate hydrophobic and hydrophobic drugs in micro or nano scale form.
Hi, I am Purnachandra Rao, CSC Department, Section B. I am telling about methods of preparation of nanoparticles. Here, I have tried to summarize the different types of methods which we use to prepare nanoparticles. There are different techniques like by polymerization, by using a polymer, by ionic gelation method, by supercritical fluid technology. There are numerous methods by which we use to make nanoparticles. Emulsion polymerization method. In this method, monomers are taken, they are dissolved in an aqueous phase which contains an initiator. An initiator is a surfactant. Then by applying vigorous agitation, an emulsion formed. And that emulsion, a smaller particle size is of around 100 nanometers in range. Here we can see it is represented as emulsion polymerization recipe. That means it contains spherical micelle. Then that micelle is swallowed with monomer, and then monomer droplet stabilized by surfactant, and then surfactant micelle is also there. And the surfactant substance, we all know that it has a 2N, hydrophilic N and hydrophilic N, and then water soluble initiator. Next method is dispersion polymerization method. It is used for preparation of biodegradable polyacrylamide and polymethyl methacrylate. Here, two-phase mixture ultrasonication monomer droplets undergoes polymerization at 75 degrees Celsius and forms nanoparticle suspensions.
I am Mazmal from CSC Department Section B. I am telling about Nanopreparation Method. The mostly widely used polymers for biodegradable nanoparticles have been polylactic acid. This is another method which is widely used by nanoparticle preparation, which is called as solvent displacement method also. It is useful for silent water drugs. The release of crystalline has been earlier sustained by using different drugs and delivery systems such as releasing hydrolysis. Crystalline is an antimetabolic used primarily for active mechanolics liquinium and mechanolics liquinium. Dialysis method. The displacement of a solvent inside the members is followed by the processive aggregation of polymer due to a loss of soluble and the formation of homogeneous suspension of nanoparticles. The dialysis technique is a simple and effective technique for preparation of polymer nanoparticles with narrow distribution. Drug and polymers are placed inside a dialysis tube. Members, after dissolving with water, mechanical organic solvents which approximates molecule weight of cutoff. The ionic gelation technique. Gelation is a phenomenon of considerable importance during membrane formation, especially for the formation of top layers. It was mentioned in the previous section that was a large number of symmetrically polymers exhibit a lower crystal content in the find of member because members formation is too fast. In ionic gelation techniques, also known as ionic indirect gelation, in which are prepared by using biodegradable hydrolysis polymers such as crystalline gelation and sodium alinate.
Hi, hello everyone. This is Mankant, Department of CSC. My friends told about preparation of nanoparticles, and I am telling about how to convert nanoparticles to nanomaterials, and I am explaining brief explanation of nanomaterials. Now I am telling about nanomaterials. At first we should know the definition of nanomaterials. Nanomaterials can be defined as materials that have at least one dimension in nanometer scale. The size of nanomaterials is 1 nanometer to 100 nanometer. Other than that, the 1 to hundreds of nanometer size that doesn't consider as nanomaterials. And we know that three types of nanomaterials: bulk materials, atomic materials, nanomaterials. Between the bulk and atomic materials, we can find the nanomaterials. Bulk materials are like mobiles, etc. Atomic materials are like metal, iron, etc. In between those materials, we found nanomaterials. Nanomaterials are
cornerstones of nanoscience and nanotechnology. These are thin materials with high potential. Nanomaterials can exist in the different forms such as particles, tubes, powders, coating, etc. Nanomaterials can be metals, polymeric metals, or composite materials. Next topic: what makes nanomaterials special? There are two reasons. First, nanomaterials have much greater surface area to volume ratio than their bulk counterparts, which leads to their better reactivity and strength. Second, also the nanoscale quantum effects come into the pictures and become much important in determining the materials properties and characteristics, leading to their behavioral, optical, and electrical and magnetic behavior. At next, we will discuss about advantages and disadvantages of nanomaterials. Advantages are the extremely small size of nanomaterials offer various different advantages compared to their bulk counterparts. Nanomaterials have high porosity, which makes them useful for various industrial purposes. Nanomaterials help in the energy generation by make the solar panels more efficient and cost effective. Disadvantages are very less is known as about information on the health and safety aspects of exposure to the nanomaterials. Nanomaterials are more likely to have higher toxicity than bulk materials if they are insoluble or biological member or even precipitate in the body.
At first, we have to say heartfully thanks to Dr. M. Chandrakala ma'am for giving this wonderful opportunity. We thought that we gave wonderful explanation about this topic. Once again, thanks to Dr. M. Chandrakala ma'am.